All right. Thank you very much. I welcome you all. This is GMT Academy, and in today's story, we're going to talk about rational and irrational numbers, right? And the course code is MSM 111. Okay, so our main focus will be on rational numbers. Then we'll also discuss irrational numbers in the next video. Thank you. So a rational number is a number in a decimal form, right? So when we say a decimal form, we're saying a number with a point, right? So a number with a point. We also have decimal numbers actually. Right, so whose block of digits terminates or repeats? For example, the first one here, the first example which we have 0.75 and you're saying is a terminating decimal, right? Then the other example, we have 0.245 and as you can see, on top of 4 and 5 here, we have a bar. So that bar is actually telling us that the decimal number is a repeating decimal, right? So what does it mean? Right, so if a number has a repeating decimal, it simply means that that 4 and 5 keeps on repeating. Yes, so it keeps on repeating and it has no specific ending point. Okay, so now a rational number can also be expressed in the form of a over b, and where a and b are integers, and this b should not be equal to 0. Okay, so these are the key notes or the key points which we will need to take. So now let's look at the examples of rational numbers in form of a over b. We have these fractions here. Okay, so these fractions which we're seeing here, right, so these fractions which we're seeing here, these are rational numbers. Okay, so now you should note that, or should take note that all integers are rational numbers. Then other examples of rational numbers, okay, so the the other examples of rational numbers are the square roots of perfect squares actually, right? So these numbers which you're seeing here, these are perfect squares, right? So when you find the square root of these perfect squares, we are calling them rational numbers. Okay, so now let's look at the examples which we have. Okay, so the examples, they are simply asking us to express the following decimals in the form of a over b, where a and b are integers and b should not be equal to 0. Okay, so we have the first one, which is 0.3, and 3 has a bar on top. We also have 0.24, where the two numbers have a bar. We also have 1.23, 0.785, 5.1, 345, and 42.3478. Alright, so now, how are we going to answer these questions, or how are we going to express these decimal numbers in the form of a over b? Right, so let's solve. Right, so now, on this part, okay, so we are saying take note that 0.3 with a bar on top can be written as 0.33333 up to infinity, because we are saying this is a repeating decimal, right? So this 3 keeps on repeating itself. Okay, so now since 0.3 with a bar is equal to 0.333, we'll let x be equal to 0.3333 and we'll mark this one as our equation 1. So once we do that, we'll multiply both sides, right? So we are going to multiply both sides, meaning x and so we're going to multiply this x and 0.33 as a repeating decimal by 10. So after we do that, we are going to have, or we're going to obtain 10x, which should be equal to 3.333. So the 3 will keep on repeating itself actually. Alright, so I was saying the 3 will keep repeating itself. Okay, so in this one, we're going to mark it as our equation 2. Okay, so that one will be our equation 2. Okay, so after doing this, what is the next step? So the next step, we are going to subtract equation 1. So whichever element we have on the right hand side as well as on the left hand side, we are going to subtract it from the elements or the numbers which we have in equation 2. So we are going to say this 10 minus x. So when we say 10 minus x, we are having 9x, which is here. Okay, then from there, we're going to say 3.3333 minus 0.3333. Right, so after doing that, we are going to get 3. So our aim is to make the decimal number be equal to 3. Yes, so once we do that, we're having 9x, which is equal to 3. So the question is saying we express the decimals in the form of a over b or as a fraction. Okay, so now we have 9x, which is equal to 3, then we divide both sides by 9, then we get 3 over 9, and we can simplify further this fraction to 1 over 3, and you conclude that therefore 0.3 with a bar is equivalent to 1 over 3. So you can try this using a calculator and it will give you exact the same thing, right? So remember, in MSM 111 or MSM 112, we don't use a calculator, right? So you should show all the steps as I've shown you actually, right? So now the second example, right? So for the second example, we have 0.24. Actually, this one is supposed to have a bar on top, right? So this one is supposed to have a bar. We simply telling us that 0.24 is a repeating decimal. Sorry, is a repeating decimal, right? So now we're going to say we'll let x be equal to what we have here. Since 24 is repeating, then we'll keep on repeating 24, 24, 24. Yeah. Then we'll mark this as equation 1. After doing that, we'll multiply both sides, the x part and the 0.2424 actually, by 100. So we'll get 100x, which is equal to 24.2424. And this we'll name it as equation 2. Right, so after doing that, we'll subtract equation 1 from equation 2, just like we did from the first example. Right, so once we do that, we say 100x minus x, we'll get 99x, then 24.2424 minus 0.2424. Yeah, so we'll get 24. Remember, our aim is to make the decimal number be equal to 0, right? So what I mean by the decimal number is that, right? So what I mean by the decimal number is that the number actually after the point should be equal to 0. Then we'll have the whole number like that, right? So 99x is equal to 24. Then we'll divide both sides by 99, and we'll get x being equal to 8 over 3. If you can't simplify further on this part actually, then you'll conclude to say 0.24 with a bar here is equal to 8 over 33. Then you are done, right? So now for the third one, we have 1.23. So we have, right, so we have 2 and 3 which are repeating. Okay, so since 2 and 3 are repeating, then we'll let x be equal to 1.232323, and this will mark it as our equation 1. From there, we multiply both sides by 100. Why we multiply both sides by 100? Because we want because from the second equation, actually, when we subtract the first from the second, we want to obtain the decimal as 0, right? So we'll end here. So how many steps are we going to move from? How are we going to move this point up to here? We have 2 steps actually. So to do that, we'll multiply by 100. Okay, so once we do that, now we're going to subtract actually 100x minus x. You're going to have 99. Then when you subtract these which you have here, you have 22 over 99, right? So if you can simplify this expression further, then you leave it like that, right? So we now go to the fourth equation actually, right? So our fourth equation is 0.785, and from this question, or from this decimal, the repeating decimals, right? So which we have 8 and 5. So 8 and 5 keep on repeating itself. Okay, so we'll let x be equal to 0.785, then we'll multiply both sides by 10, right? So we'll have something like this. Okay, so as you can see, from this part, we have not concluded actually. When you try to subtract the two, you won't obtain the decimal as 0. So what are you going to do? So you are going to shift your focus now on the repeating decimals. Okay, so now for that reason, you are going to multiply. You are going to multiply the first equation, this one, the first equation by 1000 on both sides. After you do that, you're going to have something like this. Okay, so now we'll label this one as equation 1, then we'll label this one as equation 2, then respectively subtract, right? So after we do that, we're going to subtract equation 2, the equation 2 minus the equation 1. So 1000x minus 10x, we have 990x. After you do that, so this is the final answer, right? So now the assignment which I'm going to give you is that you're going to answer